everybody. It is Mr. Gus, and I'm back in the physics classroom. Today, we are going to be adding vectors. We've defined vectors. We use Despicable Me. We defined vectors as a mathematical quantity that is represented by an arrow with both a magnitude or size and direction. So, in order for us to draw vectors, add vectors, we're going to have to understand how to add them, the convention with adding them, the right triangle geometry for finding the resultant vector, and then the trigonometry to help us understand the angle at which these vectors are going to be at. So, we're in your packet right now. I got two example problems for us to start. The first is Lisa. Lisa's going to walk east at 10 kilometers and then north at 5 kilometers. Let's draw a picture. There's Lisa. You can see her right here. Beautiful hair, okay? She's going to walk east at 10 kilometers. I'm going to go ahead and just say north, east, south, west on the compass on the page. She's going to walk east 10 kilometers. There it is. Label it 10 kilometers. This is my vector. It is a arrow represented with of a mathematical quantity with both a direction and magnitude. The direction is east. The magnitude is the length of the arrow. Now she's going to walk north 5 kilometers. Because this arrow represents a vector, we have to make sure that the arrow itself is relative in size to the other arrow on the page. So if this is 10 kilometers and this is the length I chose to draw it, and this is half of that size, this arrow should be roughly half the size of the 10-kilometer vector. Roughly, as best we can. If there is graph paper or grid paper, you want to count the squares to make sure they are even. Now, that being said, in order to find the displacement of Lisa, we look at where we started, we draw an arrow to where we ended, and that is the total displacement. That's the vector quantity that describes how far Lisa has moved from where she started. That is going to have an angle. This right here is known as the resultant vector. The resultant vector is what I'm solving for. Now, it's a right triangle, so to find the magnitude of that vector, we're going to do our little Pythag. A squared plus B squared equals C squared. In this case, we'll call A 10 kilometers squared plus B 5 kilometers squared equals C squared. We do our math. We end up with C being equal to the square root of 125, and that is, what is that? Square root of 125 ends up being 11.18. All right, 11.18 kilometers is the magnitude of Lisa's displacement. But if I just say Lisa moved 11.18 kilometers, well, there's an entire range of ways she could have walked, right? She could have walked anywhere in this circle at that distance and wound up in any number of places. So I need to be more specific. With this resultant vector, there's a very specific angle at which she moves. So I can find this angle, this theta right here. Where exactly was she displaced to? Well, she started moving east and she ended up north. So she's moving in this northeast quadrant. Let's figure out the angle that she moved. So how am I finding this out? Well, I can use any one of my trig functions. So in order to find the direction, I need to use SOHCAHTOA, or my trig functions, my inverse trig function. So I'm a fan of tangent. I just like tangent. I think maybe the way the graph looks makes me happy. I don't know. But I'm going to use tangent. So the tangent of the angle she's displaced is equal to the ratio of the opposite side component to the adjacent side component, or tangent of theta is equal to 1/2. Now, in order to undo something like a trig function, we have to take the inverse of it. I'm not dividing by tangent or taking the tangent root of it. I'm going to take the inverse tangent, meaning tan inverse of 5/10 kilometers will tell me the angle. How do you find inverse tangent? Well, on your calculator, usually these things are immediately above. So if I want to undo tangent, I would hit second and then find the tangent button over here. Second tangent undoes it. So second tangent, there it is. I get my inverse tan of 5/10. When I go ahead and do that, I get 26.56. We'll call it 26.6 degrees. My angle is now 26.6 degrees. Where? 26.6 degrees. If this is if this is east and this direction is north, she's moving 26.6 degrees northward from east. So, displacement, 11.18 kilometers at 26.6 degrees north of east. And this exactly tells me what Lisa's displacement is. Okay, let's try one more. But this time around, we're not going to do one to find the resultant vector. We're actually going to go ahead and find, where is it? The components. So this time, I give you a vector, and that vector is 13 meters at an angle of 22.6 degrees north of east. That's what this is. Now I'm asking you, what is the horizontal component and what is the vertical component of this vector? So I'm almost needing to use like side and angle geometry now to find what is the vertical component and what is the horizontal component. Let's go ahead and write our trig functions out. It's so, ka, toa. So if I want to go ahead and find this vertical component or the y component, vertical, y, if I want to find that component, I'm going to go ahead and have to use the opposite side. So my y component is going to be opposite over hypotenuse. That's the sine of the angle. Sine of theta is equal to this unknown, let's call it y for horizontal, or sorry, for vertical, over 13 meters. That algebra ends up being 13 meters times sine of 22.6 degrees. Make sure your calculator is in degree mode. 13 times the sine of that, 13 sine 22.6. I end up with 4.999 repeating, or we'll call it 5. This vertical component is 5 meters. So vertical, 5 meters. Quick check on the graph paper. If I count 1, 2, 3, 4, 5, it checks out. I can count those squares. I end up in the right spot. Let's find the horizontal or x component. In order for me to do that, x component is the adjacent side. We'll call this side x because it's horizontal. The x component, I'm going to go ahead and use the cosine function. Cosine of the same angle is equal to the ratio of the adjacent side to that angle over the hypotenuse. In this case, it's 13 meters. Do the cross multiplication, 13 meters times cosine of the angle, which is 22.6. I dropped the decimal place right there, equals x. If you go ahead and do the 13 times the cosine times the 22.6, you end up with the horizontal component of this thing being 12 meters. And if I go ahead and do a quick check, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It matches my graph paper. I get 12. I get 5 for the vector, for the initial vector, the resultant vector of 13 meters at 22.6. Now, if you've got questions, as always, drop in the comments, send me an email, ask me in class. There's extra practice in the packet if you want to do that, but this is how we add vectors to find resultants, and this is how we use resultants to find components. All right? Till next time. See ya!